I have a question here by, let me get a name. I have a question here. Let me just take this one by Monwak. I'm going to say Clement. I've got here one from Clement. And then we're talking about titration. So remember, when we talk about titration, now this is actually a very interesting topic. When we talk about titration, I want you guys to think about making the perfect mixed solution cool drink. You want to get that perfect blend between water and your concentrated cool drink, right? You use the same glass, you put 6 spoons of that cool drink every single time so you can get the perfect blend at every time. Titration works exactly the same way. They want to neutralize a base and so forth. But then the trick is they use indicators, right? And these indicators then show or tell us when the end point has been reached. But one important thing to remember, we have 3 indicators that we use in grade 12. Well, in my class, we use phenylephthalin. Well, most of the time, depending on what you are using, but that's the most common one that we use. Now, in grade 12, Clement, what they might ask you, they might give you a reaction or a story telling you Tobile is mixing sulfuric acid with NaOH and she is titrating them and she reaches endpoint, right? And then they'll tell you she uses phenylephthalin. What color will her solution be? Or she uses methyl orange or bromothymol blue, and what color will her solution be? Now, the trick is you need to know this table like out of your head. Unfortunately, it's one of those things you must read before you go to bed, Clement. So one way I remember it, or how I teach my kids, I will have indicators. I'll have indicators, and then I will have pH range. And it's actually so fun if you're actually doing these experiments in class. Color, and then we've got color here again. Unionized, ionized, and the color ionized. So these are just headings. So now, remember, the first indicator we have is methyl, and this is in no order. Methyl orange. Now, the pH range for methyl orange will be between 3.1 to 4.4. Just want to take you back to one of my beautiful drawings here. When they talk about pH range, this is the pH scale. When we talk about 3 point something, 4.4, it means it is in this area. When I talk about 7.1 to 13.9, it's more in that area. So unfortunately, you must remember it. So color unionized, it will then be red, but the ionized color will be orange. So in solution, it will change and it will become orange. Then we've got bromothymol blue, and it will work in a pH range of 6.0 to 7.6. It will be yellow, and it will be blue. I want to take you guys back a little bit. Remember when we were doing equilibrium constant, and we're talking about Le Chatelier's principle, and they had given us an equilibrium, right? And they told us maybe we add more concentration on this side and then it shifts to this side, but it shifts blue. And by it giving us color, we were able to say more of what was added was the concentration, the temperature, or the pressure changed, or so forth. So I want you guys to think about indicators the same way, because if you're titrating, let's say with phenylephthalin, because it's one I use most often, if it turns that light pink, it means the end point has been reached. If you add more and more and more of the acid, it's going to go dark and dark and dark pink, meaning you have too much of the acid and then you must add more of the base to get that light shade of pink, right? So I want you guys to think of it like that. The color that the indicator changes into determines what's actually going on inside the solution. Another one, phenylephthalin, and this is at 8.3 to 10, and this is actually a colorless one. Colorless and ionized, it will then be magenta. It'll then be magenta. So remember, when we are doing titration, we have to use an indicator. And the indicator then actually assists us to tell us what is going on into solution.